Welcome to this video on Year 1 Statistics Chapter 7 Prep Consolidation Answers on Hypothesis Testing. So question 1, what is a critical region? Well, a critical region is the region which, if the test statistic falls in this region, then you reject the null hypothesis, the H0. And so it's either one region at the extreme right or another region at the extreme left, or two regions consisting of extreme left and extreme right, depending if it's a one-tailed or two-tailed test. The relationship between critical region and the number of tails in a hypothesis test: a one-tailed test will have one critical region, a two-tailed test will have two critical regions. C, a hypothesis test at 5% significance level usually means the critical region for a one-tailed test has a single critical region with an actual significance level of at most 0.05. Of course, we calculate the actual significance level by looking at the size of the critical region. That's the probability of lying in the critical region once we've calculated the critical value. A two-tailed test has two critical regions with total actual significance level of at most 0.05. And that usually means that each tail is at most 2.5%. So we don't allow either tail to be more than 0.025, unless the question suggests otherwise. Sometimes the question will say as close as to 2.5% each tail as possible. And if that's the case, then we try to find a number as close to 2.5%, which might be slightly higher than 2.5% in some cases. Question 2, a random variable has distribution binomial 16 probability p. A single observation is used to test the hypothesis that the null hypothesis that p is 0.4 and the alternative hypothesis that p is less than 0.4. You use a 5% significance level to find the critical region of this test. Okay, so we're going to need to use the calculator for this, the class Wiz, so I'll just make that available. And we're going to need to get a table of values that will help us to work out where the critical region is. Now, if we do n times p, which gives us the mean, 16 times 0.4 is 6.4. So p less than 0.4, we need to look to the left of 6. So 0 to 4 is about right. So let's go to menu 7. Binomial CD, we need to go down, 1 for binomial CD, and then we want the list, 1. And then, as I've written here, I want values of variable 0 to 4. So 0, 1, oops, let's do 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. Let's just do 5 as well. Okay, and now if we put n is 16, and p is 0.4, because that's given by a null hypothesis. When we look at the table of values, we should see the probability of being less or equal to 0 is 0.00028. The probability of being less than or equal to 1 is 0.0032. Less or equal to 2 is 0.018. That is more than, no, that is 1.8%. Less or equal to 3 is 0.0651. That's 6.5%. And less or equal to 4, if I just go down, is about 16%. So if we look at the 5% significance level, the one that is less than 5% is less or equal to 2. But being less or equal to 2 is less or equal to 2 is 0.018. Yes, is 1.8%. Okay, whereas the next one is more than 5%, it's 6.5%. So the critical region is x less or equal to 2. The critical value is 2. Now write down the actual significance level of this test. Well, the size of the critical region, probability of lying within the region x less or equal to 2, we can see is 0.0183 or 1.83%. So that's the actual size of the significance level. Is a test statistic of 3 out of 15 significant? Well, because 3 does not lie inside the critical region, then it's not significant. So we retain H0, we do not reject H0. We could have done a p-value test, but because we've already worked out the critical region, it's not worth working out the p-value. The p-value would have been the probability of being less or equal to 3, and that would have been 6.5%, which being greater than 5% would mean it's not significant. Question 3, the standard treatment for a disease is effective in 86% of cases. A new treatment is claimed to be more effective. A clinical test finds the new treatment to be effective in 33 out of a sample 35 patients with disease. The effectiveness of a new treatment is tested at the 5% level. So state the hypothesis and whether the test is one or two-tailed. Well, the null hypothesis is that the standard treatment has a probability of 0.86. We can't have the null hypothesis being that it's higher than that or lower than that. It has to be an actual figure. So that gives us a clue that P has to be equal to 0.86. The alternative hypothesis is that maybe it's increased for new treatment, so P is greater than 0.86. And therefore, if we're looking for only improvement, if we're only looking for P being greater than 0.86, that means it's a one-tailed test because we're only looking at the upper tail. Write down a suitable distribution to model the number of effectively treated patients out of 35. Well, we can see it's going to be binomial. We'll then be at 35, and the null hypothesis gives us the P of 0.86. State the test statistic. Well, the statistic is from our sample that 33 out of 35 patients were effectively treated. So that's 33 out of 35. Test whether the test statistic is significant or not. Well, we can either work out the critical region and see if 33 out of 35 is in that critical region, or we can use a p-value for 33. Okay, so let's first of all work out the critical region by going to, again here, n is 35, e is 0.86. Now we want to get values of x, and we can see that the relevant ones we're likely to need. And you can check what roughly you need by taking 0.86 of 35 and then realizing you need to be higher than that. So let's look at 31 and higher. So 31, 32. You might have to play around with the values until you get in the area that you want. So it may be a bit of trial and error. 34, and I'll do 35 as well. So if we press enter, then we have the probability of being less or equal to 31 is 0.7414, etc. Okay. So now looking for the critical region, we can see that the probability of having less than or equal to 33 patients effectively treated is 0.9658. So the probability of being 34 or more is going to be 1 minus 0.9658. Okay, and so that is the critical region, x being greater than or equal to 34. Okay, because 33 does not lie in the critical region, it doesn't lie in the region x greater than or equal to 34. It means that 33 is not significant. Therefore, we retain H0. We do not reject H0. Or if we're using a p-value test, the probability of being greater than or equal to 33 is 1 minus the probability of being less than or equal to 32. The probability of being less than or equal to 32 is 0.8854. So the probability of being greater than or equal to 33 is actually 0.1146, which is about 11%, and that's more than 5%. So it doesn't lie in the critical region. Probability of being 33 or more is not significant. So a test statistic of 33 does not lie in the extreme region to reject H0. So that's using the p-value, or you could use the critical region. State your conclusion and make a suitable comment. So we have to make a comment mathematically, and we have to make a comment about the situation. So there's insufficient evidence to reject H0 at the 5% level, one-tailed. Insufficient evidence that new treatment is effective at 5% level. So probably needs a larger sample to test for possible increase in effectiveness. So the fact that we haven't got enough evidence doesn't mean that the new treatment isn't more effective. It's just that we haven't got sufficient evidence that it has improved. State the actual significance level used. So the actual significance level is the size of the critical region, and that's the probability of being greater than or equal to 34. And we saw that was 1 minus the probability of being less than or equal to 33, 1 minus 0.9658, which is 0.0342 or 3.42%. So don't just say it's 5% because we're trying to test at the 5% level, work out the actual size of the critical region. Okay, I hope that helps.